So in this video, we're going to be talking about how to write exponential functions. So by now you should have an idea as to how an exponential equation looks like and the difference between exponential growth and decay on a graph. And that's going to be really helpful to understand this video here. So first, we're going to start with creating an equation from this table right here. So to create the exponential function, you need to know how much the f of x is changing, also known as your y value, each time. And you're going to need to find what the initial value is, which is also known as your starting value or your y-axis. So for this example, we're going to go ahead and first look at the change that is happening. Assuming these are all exponential functions, what we're going to be working with today, we are going to see how do we get from 3 to 9, how do we get from 9 to 27, 27 to 81. And if you thought multiply by 3, you're correct. So you do multiply by 3 every single time, and that's one way of knowing that it's an exponential function. Now, it's not always going to be obvious, but for this just beginning example, it's going to be something as simple as that. So the number that was multiplied each time, which in this case was 3, is the base of the exponential function. So the base is 3 in this case. That is also known as your b value. And the f of x value is where x is 0 is our initial value. In other words, our starting point. So we have our starting value right here. Whenever your x is 0, that is your y-intercept. So my initial value, also known as my a, is going to be 9. Once you have your initial value and you have your base, now you could go ahead and plug it into your exponential function equation. Your general formula for your exponential is f of x equals ab to the x power, where a is your starting value, your initial value, and b is your base or your multiplier. So the exponential function for this table here would be 9 and 3 to the x power. Take raised to the x power, not times x. So we're going to do a couple practice problems here. Create an exponential function for the following tables. So you need two things. You need to know what your multiplier is, or your base, and you need to know what your a value is, which is your starting value. So the easiest thing to see from a table right away is your a value or your starting value. And your a value in this case is 1. That is your starting value. Now we're going to see what our b value is. What is our multiplier each time? And what number does it look like is multiplying to get to the next number? In this case, it's fairly obvious, hopefully we can see that it's multiplying by 5 each time. So our multiplier is going to be 5. Alright, so again, starting value, multiplier, goes right there. So next example, we're looking at the same thing. Our starting value is wherever our x is equal to 0. That's our starting value. So my starting value is 3. And now let's go ahead and take a look at what do I do to get to the next number. So it might not be so obvious for this example right here, or for these points, but if you look at the next one, hopefully you see that each time you're multiplying by 10. So, because you're multiplying by 10 each time, your base is 10. So it's going to be 3 parentheses 10 raised to the x power. The exponent, it's up at the top right hand corner. It's not next to it. If this was not obvious to you, if you didn't see that it goes to 10, there is a very effective way to see what your multiplier is. And this is going to be really helpful for like a Khan Academy on this, where it's not always obvious. And you always do the next term divided by the previous term. And it has to be the previous term, not 2 before, 3 before term. So in this case, if we do, let's say 300 divided by our previous term of 30, if you divide that, that will give you 10. Okay? And if you did 30 divided by 3, that will also give you 10. You see the same thing here. If you do 125 divided by 25, that will give you 5. If you do 25 divided by 5, that will also give you 5. Or if you do 5 divided by 1, 5, next term divided by the previous term, then you will still get the multiplier or the base. So this is very helpful. This here, I will definitely have a note of that somewhere, because it's not always going to be obvious what your multiplier is. So this is a perfect intro into these next types of charts where your multiplier is not obvious. So goes from 40 to 10, 10 over 4, 10 over 16. And it maybe for some of you that did notice 40 to 10, maybe you see a pattern that it's dividing by 4. Hopefully we see that. 40 divided by 4 is 10. 10 divided by 4 is 10 divided by 4, 10 over 4. But how could we figure that out if we didn't see it from the first hand? So if you recall, the next term divided by the previous term, that is going to help you here. So let's just use that trick. The next term, 10, divided by the previous term. And that simplifies to 1/4. So with this in mind, you see that your multiplier is not 4, even though it's dividing by 4. It is actually 1/4. So 1/4 would go here. And we are going to now look for my starting value. My starting value is where your x is equal to 0, and that is 10. So for this next one here, we're going to be doing the same thing. I like to start off with my starting value, where my x is equal to 0, my y is 64. So that is my starting value. That is my y-intercept. And what is my multiplier? What do I do each time to get to the next number? And some of you might see what it's dividing by each time. And if you see that it's dividing by 2 each time, then you could say that your multiplier is 1/2. So this is very similar to geometric sequences. Your multiplier is not 2. So let's go ahead and use that formula of the next term divided by the previous term. Let's just do 32 divided by 64. And it could have been any of them, any pairs that you could have selected. Okay, 32, 64, and that does simplify. If you keep on simplifying it, it simplifies to 1/2. So my multiplier is 1/2 raised to the x power. So let me just put this down here. 1/2 to the x power. So this is how you write an equation given your table. And this is also moving into how do we write an equation from our graph? So the two things that you need, a b to the x power, where your a is your y-intercept and your starting value, and your b is your multiplier. So let's go ahead and take a look at this example here. And I'll go ahead and stick with the same colors. So I'll do A as my y-intercept. So we have our graph right here. So our y-intercept is very easy to see at 0, 3. And we're going to go ahead and write that as 3 as my A value. Now I'll have to find out what my multiplier is. And how do I do that? Well, let's go ahead and take a look at what is my y when my x is 1. So we have a point right here, and the point is 1, 6. So it went from 3 to 6, and this is an exponential. So that means it multiplied from 3 to 6. What do you have to do? You multiply by 2. We don't add 3. This is an exponential function, so it has nothing to do with adding. It's multiplying each time. So that's why I didn't add. So 3 times what gives me 6? 2. So that is actually my multiplier. And this table here is just kind of a way for you to see, to plot your points down. And you can also see it clearly from a table that it multiplies by 2. And if you actually graphed your second point and it kept on going upward, it would be at 2, 12. Let's try another one. So this is nicely labeled for you. Starting value, multiplier. I'm going to go ahead and start with my graph, go with my table, and then make my equation. So my graph has a value of 0, 2. It has a value of 1, 3. And again, in this case, it's not really that obvious what I multiply my 2 by to get to 3. It's an exponential. It's a multiplier that exists. But if you recall our previous notes, it's always the next term. To find your multiplier, it's the next term divided by your previous. So in this case, our next term is 3 divided by my previous. So my multiplier is 3/2. And it's just a coincidence that it ends up being the same numbers. But this would usually simplify more and become a different fraction. But in this case, it's 3/2. So to get to my next number, I would actually multiply by 3/2. And that would be 9/2. Okay, and that is not shown on our graph, but that's how we could figure out our table. So our starting value here is going to be, again, where's my x equals 0? Right here. So therefore, that is my starting value. That is my y-intercept. And that is why it is my starting value, 2. What is my multiplier? My multiplier is 3/2, 3/2. And now I can write my equation. Y equals a, b to the x, and that becomes y equals a, which is my starting value 2, b is my multiplier to the x. Same thing in this example. And if you didn't previously know, just to mention, that this makes sense because 3/2 is larger than 1. And when your b value is larger than 1, it's going to be growing exponentially. Let me start by plotting my points onto my table here. We have 0, 5, and then we have 1, 2. And how do I find my multiplier? It's always my next term divided by my previous term. So my next term is 2. My previous term is 5. So my multiplier is 2/5. And I guess you can say it's just these two numbers switch. That's your multiplier. That's if your x values are going in order, like 0, 1, 2, 3. If your x values were skipping a number, this wouldn't always be the case. So just watch out for that. We're going to do the same thing to find my next term. Multiply by 2/5, which would give me 4/5. So going back to my starting value, my starting value is where my x equals 0, and it's not always going to be the first one at the table. It's wherever your x equals 0. So for example, at the previous problems up here, it wasn't the first number, it's where your x equals 0, your y-intercept. And you can also see it on the graph here, your y-intercept. Starting value is 5, and my multiplier, as we just saw, is 2/5. So now we're ready to write out our equation. Y equals A, which is my starting value, times B, which is my multiplier, or your base, to the x power. All right. We're going to look at now, how do we graph an exponential equation? So you can make a table, and for now we're going to go ahead and just know the parts of your exponential function. If you know the parts of your exponential function, it makes it a lot easier to figure out. So in this case, that first number, that A value, is your starting value. It's your y-intercept. So where's your y-intercept? 5, right here at 5. And that 3 tells me that it's your multiplier. So I go from 5 and I multiply by 3, and that's 15. So for 1, you're going to end up at 15. And that's going to be your second point. If you didn't really understand that, I'm going to go ahead and use the second method here to graph, and that's basically plugging in your points. So if you make a table, I could just start by using, let's just use -1. Let's do -2. -2. And you could just plug in points to your equation and see what you get. So 5, 3, and you're substituting -2. And what -2 does is it actually flips this and moves it to the bottom. So this becomes 5 times 1/3 to the second, which is the same thing as 5 times 1/9, which is the same thing as 5/9. Okay, so this is 5/9. So at -2, you have a point at 5/9, which is pretty small right there. And you do the same thing for the next one. 5, 3, because that is what my equation says. And then to the x power, my x is -1. And I get that negative exponent flips that number, so it becomes times 1/3, which is just 5/3. So at -1, we have 5/3. -1, 5/3, which is somewhere right there, like 1 2/3. And we just keep on going. Plug in 0. Anything to the 0th power is just 1. So this is simply just 5. And that makes sense because my starting value, when x is 0, my starting value is 5. 5, 3, 1. That's going to be 15. And that's how I got that 15 earlier. Okay? And then we do the same thing. 5, 3 to the second. 3 to the second is 9. So it would be 245, which in this case we can't really graph that. So we are going to graph this. And very important to note that the smaller this x gets, -3, -4, -5, it is always going to be extremely close to 0. It's going to be a very, very small number, but it will never actually get to 0. So this here is called an asymptote. And for this lesson, I'm not really going to go into too much detail. It's just important to know that because there's an asymptote, this will not ever touch the x-axis. So don't draw a graph that goes through the x-axis because that will be incorrect. I'm going to do one more example here. So once again, you can look at it from two ways. You can always start off with your starting value at 10 and then your multiplier. So it's telling you multiply by 1/2 to get to the next number. So 10 times 1/2 is just 5. So for when x is 1, it's going to end up at 5. And to get to the next number, you multiply by 1/2 again. 5 times 1/2 is 5/2, which is 2.5. And then you just keep going. So that's one strategy, or you could just do the strategy that we did, which is creating a table. And that's how you have hint, make a table. I'll just do -1, 0, 1. I'll do 2 as well. -1, so 10 to the 1/2 to the -1. So what this -1 does is it flips this fraction. So it becomes 10 times 2 over 1, which is 20. So when your x is -1, you actually have a point at 20. And we do the same thing with 0. Anything to the 0th power is 1. And that is why it makes sense to get 10, just like we see here, the y-intercept, and it's visible in our equation. We do the same thing with 1. 10 times 1/2 is just 5. And then we do the same thing with 2. This will be 10. 1/2 to the 2nd power is just 1/4, because 1/2 times 1/2 is 1/4. So this becomes 10/4, or 5/2, which is what we plotted here. So this is enough to just kind of do a sketch. And again, just like the previous ones, it's going to get extremely close to our x-axis, but it's never actually going to reach it because it will have an asymptote there. The only time this changes is when you have a shift in your exponential functions, which in this video I'm not going to talk about just because it's more of an introductory. Alright, so that is all for this video.